Today, we're going to look at the other side of annuities. Yesterday was retirement savings, where you put a specific amount of money in at regular intervals. Today, we're looking at loans and mortgages. The loan payments to a bank are regular periodic payments characteristic of an annuity. Typically, with most loans and mortgages, you send them a payment every single month. As you pay down the loan, you have to pay less interest because there's less left on the loan. So because you're paying it at these regular periodic payments, this is an annuity, and we have to use one of these more complicated formulas. For today's formula, we're going to use the present value of an ordinary annuity, which is capital A. Don't get this confused with the compound interest formula. This capital A is present value. This is the amount borrowed. At the present, when you make the loan and you take out that loan or you take out the mortgage as you buy your house, that is the amount you owe. Capital R is once again monthly payments, and you're going to see lowercase r for rate and n for compounding periods in these formulas as well. The formula for present value of an ordinary annuity is similar to the one that we saw yesterday, only here the values should be going down over time instead of going up. The capital R, which is your monthly payment, or in some cases it can be a different rate, but usually it's monthly, is not in the fraction. So I saw some people's work yesterday where the R was in the numerator. It is multiplying the entire fraction. In the numerator of this fraction, we have 1 minus, in parentheses, 1 plus the APR over the number of compounding periods per year, there's our R over N, to the negative NT. And this is all over R over N. So yesterday's formula had 1 plus R over N to the positive NT, then minus 1. You can see the similarities here. But again, the R is in front of the fraction. Do not put it in the numerator. Here's an example for one of these problems. You purchase a house for $250,000. And for these problems, we're going to assume that you are taking out the loan for the entire amount of the house. We're going to find the monthly payments required to pay off a 30-year mortgage with an APR of 5%. These are monthly payments, so N is 12. The amount that you purchased for the house for is the present value, the A. We're going to find the monthly payments for a 30-year mortgage, that's our time, with an APR of 5%. So when we plug into the formula, our present value, $250,000, is equal to the monthly payment, which is what we're trying to find, times 1 minus, in parentheses, 1 plus the rate, 5% is 0.05, over N, number of compounding periods per year, raised to the negative NT, negative 12 times 30. And a 30-year mortgage is a fairly typical length of time for a mortgage. You can get 20-year mortgages and 15-year mortgages, but most people don't have the amount of cash ready to pay the amount monthly in order to pay off a house in that short of a time. So 30 years is kind of a standard loan. In the denominator here, let me not forget that, we have 0.05 over 12. So I'm going to do the calculations at the end of this video because my computer does not like to go to the calculator and then back to right again. But when we do this calculation, we're going to put this entire fraction in the calculator at once, and then we're going to take 250,000 and divide by that whole number. What we should get in this case is a monthly payment of $1342.05. So you buy a house, the purchase price is $250,000. In order to pay off that loan over 30 years, every month you have to send them $1,342.05. So the next question is, how much will you have paid over the 30 years? Every month you send them $1342.05 for 12 months a year for 30 years. When we multiply this all together, we get $483,138. Remember, the purchase price was $250,000. Over the 30 years, you have paid $483,138. Everything above the $250,000 is interest that you've paid. So if we take the $483,138 that we paid and subtract the original purchase price of $250,000, that means we will have paid $233,138 in interest, which is almost as much as the original purchase price. When you have a mortgage, you end up paying a whole lot of money in interest. And being able to get a mortgage with a slightly lower rate can be a huge advantage. If you can afford to pay it off sooner, that can be a huge advantage. But there's a reason people get mortgages. Most people do not have $250,000 sitting around to buy a house. So they need to take out a loan and pay it off over time. There's some tax breaks for paying off this interest. So this isn't the whole story, but be aware that these interest amounts are going to be very high. So then we're going to change this situation slightly. Your same mortgage, so we still are borrowing $250,000. You decide to send payments of $1,600. You have to pay $1,342.05 to pay it off in 30 years, but you decide that you can afford to send $1,600 per month in order to pay it off. So we want to know, when will this mortgage get paid off? The loan amount is $250,000. Our monthly payment is now $1,600. And again, that's outside the fraction. In the fraction, we have 1 minus 1 plus our rate over 12 to the negative 12t. We're going to find the time when this is the monthly payment. And this is all over 0.05 over 12. My suggestion with these is to graph each side, put the 250,000 into Y1, and put all of this into Y2, and get a graph to show where they intersect. And again, I'll show the calculator work in a minute. When you solve this, and we're going to have to round these, you get approximately 21.1 years. So you've paid the mortgage off almost 9 years sooner. The question is, how much interest will you have paid paying it off this way? So now we're for 21.1 years, 12 months a year, we're sending $1,600 a month, which is $405,120. If we subtract the original amount of the loan, the amount of interest in this case is $155,120. So you sent about $260 more each month, and you have paid $233,000 versus $155,000. You've paid about $75,000 less in interest because you've paid it off sooner. It's great if you can afford to pay it off sooner. I'm going to go back to this calculation and look at what it looks like in the calculator. So we want to plug the entire fraction into the calculator to start. And again, if you have the fraction bar as an option, I would definitely recommend using it. If you do not, you need to put parentheses around the entire numerator and parentheses around the entire denominator. So we're plugging everything that's in this fraction. My exponent is negative 12 times 30. And then in the denominator, I have 0.05 over 12. You can use the fraction bar for those fractions as well, but you do not need to. You're going to find that value. Then we want to take the 250,000 and divide by that number. If you can scroll up and highlight, you can copy it down. You also all have the option above the negative sign where it says answer. If you hit second and the negative, it'll put the answer there. So let me do this right. We're going to divide by second answer, or scroll up and copy it down. this is where the 1342.05 comes from. Notice there's parts of a cent remaining here. Typically what happens with a mortgage is you pay the exact same amount every month except the last month when you make up for all these little parts of the cent that have been lost. The second problem we had here, we were solving for the time. I would recommend doing this graphically. So you're going to write everything into the equation, and then you're going to go to the grapher, and we're going to put the 250,000 in one equation, and we're going to put the other side of the equation. So our monthly payment was $1,600, and you need a multiplication sign before you put the fraction in most of these calculators. I would just do it if you're having any difficulty. That could probably solve it. 1 minus 1 plus 0.05 over 12 raised to the negative 12x. X is our number of years, and in our denominator we have 0.05 over 12. Now, we need to set up a reasonable window for this. Our x-coordinate is the number of years that you're paying the loan off. You cannot pay it for less than 0 years, and the original loan was 30 years, so if we're sending more each month, the x max will be 30. We will definitely pay this off in less than 30 years. On the y scale, we're not going to have negative amount of dollars. And the amount that we start owing is 250,000. So let's go up to maybe 275,000. And if I graph this, what you're seeing at the top is the line where it's $250,000. That's the amount that you're paying off. And then what you're seeing in this curve is how much you've paid off over time. And what we want is the point of intersection. Calculate option 5, intersect. First curve, second curve, put your guess somewhere near the intersection. And there's that 21. It was 21.10. I'm going to have you go to 2 decimal places with all your calculations. The worksheet is posted, and you're not doing all the problems again, but just check the numbers that you need to do. Tomorrow, you're going to do a bunch of different situations with both of these formulas, and Thursday, there's going to be an assignment with annuities that will be graded.